I want to take a minute to talk about polar alignment. When you start advancing beyond just doing visuals and short exposures with a camera attached to your telescope, you want to start getting into more accurate polar alignment. And I spent a lot of time kind of being nervous of that term, saying, well, what the heck is polar alignment? What's this mysterious thing that sounds so difficult to achieve? And how can I do that on my telescope? When you mount this to the tripod, onto the top of the tripod, there's that bolt that kind of screws up into the bottom of this to hold it on. What we want to try to do for more accurate long exposures and more accurate tracking as this all moves through the night sky is have our polar alignment as accurate as possible. So we want to first start by facing our tripod north, as more accurate as we can to the north celestial pole. For us, we start by aiming to the North Star Polaris. And setting this dial here, when you get this home, you'll be able to take a look at it, according to where you are in your latitude measurement. So when you put that longitude and latitude measurement into your hand controller, it coincides pretty much with this graph here. So we're at 33 latitude. So there's a little arrow on the mount here where you can see we're kind of aligned close to 33. So if you pointed this with a compass as accurately north as you could and you had that close to 33, you can look through your polar scope and hopefully see Polaris right in the eyepiece. So what the mount gives you the options to do with these controls is to fine-tune your alt as measurements. Now again, you can search the internet and get a lot of very detailed explanation of what this all means and directions and how many degrees of adjustment we can get into, or you can just jump in there and do it and learn about it as we go. So what we want to hopefully be able to do is point the tripod legs directly north, have this little gauge as accurately set to our latitude as possible, and then as it starts to get dark and you can see the North Star, Polaris, you'll look through this polar scope and you'll be able to see it. Now you can't see it like this. What ends up happening is that you have to turn the whole situation. Let me back it up just a little bit. So right up here we've got where the polar scope kind of, you can see right through here. And there's a little cap on the end here. So you take this little cap off. Don't lose it. Put it right down there. And then you have to rotate this telescope out of the way. And what that does is it opens up a little hole in the arm here so you can see through here. And now what you do is you really just get right down here and you look through here. So depending on how high you have this and where you put it, you look through and you can see, oh, that the reticle inside this thing has some markings on it. I can see the Big Dipper, I can see Cassiopeia, I see a circle in the center with another little circle on the outside ring of it. That's where we want to put Polaris. So there's a lot of ways, again, you can do measuring things here to figure out where Polaris should be. You can get into other apps and things that will show you on a clock-like face where to find and where to put Polaris. You can turn your mount here in this direction so that the little drawings of the Big Dipper kind of line up with where they are in the real sky, right? And then that moves that circle right to where you want it. Now with these connections or these adjustments, we fine tune to move the star that we see to the little circle where we want it. So again, looking through, I can see, if I can see it. If you can't, you got to look up ways to find Polaris. It's easily, quote unquote, easily detectable using the stars from the Big Dipper and your your latitude degree north. off the horizon, you can find it. If you can't, a lot of times what I'll have to do is I'll be down here with my laser pointer because I can see it in the sky, and I'll point my laser pointer at it and then look in the little viewfinder here and try to say, oh, there it is. And you might realize, oh, there's Polaris all the way off on the side of my little screen here. So now, with these adjustments, I can tighten and loosen this thing. These are going to tilt the mount upward on this degrees. We should be close to our 33 or wherever you're setting up. And then these two in the front, you know, you'll tighten and loosen them, which will actually turn the mount this way. So you'll tighten one side, you'll see the whole mount kind of moves like this, so the star in our little hole kind of moves to where we want it. And you'll use these adjustments to get that star right on the circle where we want it to be. The more accurately you align this, the more accurately you're going to be able to track longer camera exposures. For visuals, this is helpful. Your go-tos, your star alignments and things are going to be a little bit easier. It really becomes important when you're taking long exposures, because you're going to want to take a picture that's 1 minute or 2 minutes, and so having it perfectly polar aligned means we're only worrying about tracking the night sky on one axis, this one, and this is lock solid. If you're not perfectly polar aligned, then you're asking the mount to track the night sky in this axis and this axis and keep track of that for you. So perfect polar alignment is going to allow longer camera exposures. These knobs here adjust, there are 2 screws, left and right, turns the whole mount slowly. These knobs here adjust the mount up and down, so you can place Polaris right on the little circle where you think it's supposed to be. Like I said, there's apps and web pages and books to show you, based on your time and day and your location, exactly where on our little circle that's in here you want to place the star Polaris. That will help you start doing longer camera exposures.